And let me start sharing my screen. So we have completed the define and measure phase. We have a long ground to cover though. We need to complete the analyze phase, which is considered to be slightly lengthier. And after this, we will have to complete improve phase and control phase. There will be a lot of calculations throughout. So until measure phase, whatever calculations we have done, you should be aware of all those things. And the calculations, let me tell you that the calculations which are supposed to come your way now would be even more lengthier. Okay. So
you can do it from your own exercise and then I will repeat it, yeah?
Yeah, sure. But in that way, my only thing is you will not be able to, put your thought process together. Tomorrow I'm concerned about your interviews.
Yeah.
Anyways.
But let's start at least and then I'll figure out for mine as well, yeah?
Yeah, sure. No problem. So now we have to discuss the analyze phase. We will have to identify all the potential inputs. Six Sigma, as I've told you, is nothing but this simple equation y is equal to f of x. Y is the output. Output is dependent on multiple inputs, right? If you have only one input that is impacting your output, then you will say only one x is impacting. If you have multiple inputs that are impacting your output, then I say x1, x2, x3, x4, so on and so forth. So now, we need to list all the potential inputs which are going to impact my output. Then all these inputs might not be relevant. For example, take the mileage of vehicle. If that is the output, mileage, then what are the inputs that might impact? Can you give me a few examples, Anuj? If I want to focus on mileage as the output.
Yeah. One is the output fuel, and then the driver who is driving is how is the mechanism of the car.
Okay.
There are so many things which are dependent.
Yeah. So you are telling me that vehicle, car, engine capacity, how many people can be seated, air pressure, right? What is the horsepower? Exactly. Fuel, type of vehicle, make of the vehicle, all these are going to impact. But along with that, you have also named few more things like the driver who is driving, at what speed he is driving, which gear he is frequently driving. Are you driving in city or in highway? So Anuj, let me tell you that there are two types of X's. That is inputs. One type of input is called as independent input. Independent input means it doesn't have any dependency. Dependent input means they have some other dependencies. And second type of inputs are controllable inputs and something which you cannot control. I have to consider only controllable inputs for my Six Sigma project. Who is the driver? At what speed he is going to drive? Right? What will be the road conditions? What will be the traffic? These are few things that I cannot control. Company which is selling doesn't really know who will be driving the vehicle. Yeah, so because of these reasons, whenever you're selecting inputs, select only something that is controllable, something which you can control from your end. You should never select something which cannot be controlled. For example, driver, you cannot control who is going to drive. At what speed he is going to drive. Can we control? No, we cannot. It depends from person to person. So always select those inputs which can be controlled by you. All right, that is one thing. So all those controllable independent inputs which are critical will be identified in your step 8. Then comes your verify whether the inputs that you have selected are sufficient to build your model or not. Now let me go. So what do you do in analyze phase? Analyze phase is used to narrow down the list of potential inputs to a validated list of vital few inputs. So if I have 100 inputs that I've identified, I should be focused on only the critical 10 inputs, which are going to have an impact on the project Y. All right, let me move on. So these are the various inputs. We need a project charter. We need to know what is a project Y and what are the potential inputs that you have. And what is your goal for improvement? Do you want to reduce the number of defects? Do you want to increase the productivity? Do you want to reduce the rework? What is it that you want to do? That is a goal for improvement. Then in analyze phase, what is the key objective? Objective is use the facts and data to narrow the list of 100 inputs or more than that potential inputs, these potential inputs, to validated vital few critical inputs, yeah, that have an impact on the project Y. Then we come up with the validated vital few inputs. Let me just quickly get this on track. There is only one objective, and this is the vital few. Vital few inputs is what we are going to get. The same thing is depicted even in the diagram which is shown in the bottom. My bad, just a minute. All right. Okay. So look at this diagram which is going to depict the same thing. There are a list of potential inputs. Collect the data for those inputs. See whether they are statistically significant and practically important or not. If yes, they are important, then ask another question. Can we meet the goals? The goal of increasing the quality or increasing the productivity or reducing the rework, these kind of goals, can you meet with those inputs? If the answer is yes, those are the vital few inputs for you. If the answer is no, in this case here or in this case, you come back to trivial many X's. Yeah. So there are trivial many things which are very trivial. We are least bothered about the trivial things. We should always be concerned about the vital few critical inputs. All right. Let us move on to the next slide. All processes have variation. We need to acknowledge this first of all. All processes will have variation in the system. So the output, that is a sample data from a process, will vary due to natural variation in the process. For example, if you're going to office daily, from your home to office, daily you're not going to reach exactly at 9 a.m. Suppose you want to be in office by 9. Will you exactly be at 9 in the office? No. Sometimes it might be 8:55, sometimes it might be 9:05, sometimes 9:04, sometimes 9:03, sometimes 8:56 or 8:57 or 8:58 or 59. So it's not going to be exactly 9. There will be some variation. And that variation is because of natural variation of the process. Naturally occurring variation. And when we observe the output, how can we be sure that the variation is due to natural process variation? Or if the process has really changed? How to find out that? Step one is all processes have variation. We have to acknowledge that. Samples from a process may vary. So when you look into the sample for one point from a sample you might get here, another might be here, so on and so forth. So hypothesis testing differentiates between sampling error and true process differences. So if you're doing some error while picking up the samples, right? Though always remember this, simple random sampling is the best mode of sampling. But however, you have thought that, oh my God, there are two machines which are going to manufacture Coke. Each machine is going to manufacture 100 Coke bottles in 1 hour. This machine also is going to manufacture 100. You know for a fact that you need to do simple random sampling. That is, close your eyes, blindly pick 10 or 20 from these 100. Yeah, but if you're doing some kind of a sampling error, that means you're picking the first 10 bottles which are manufactured out of these 100, or you're picking last 10. So if you're putting some kind of constraints like this, then there would be a sampling error. Sampling error will be there, but higher sampling error might arise. So how to get rid of this sampling error? You can get rid of the sampling error using hypothesis testing. Yeah, you have to get rid of this using hypothesis testing. Next thing is hypothesis testing problem flow. First, there will be a practical problem. State that current problem in words. Let us take one example. Experience level of employees play a role in productivity. So experience level is a vital X. But we need to translate that into a statistical problem. In statistics, always you use mean or variation or both. Right? This is translated into statistical problem in terms of mean or variation or both. Let us see this example as well. The mean productivity of people with experience level A is different from the mean productivity of people with experience level B. So here you are telling that experience level of employees plays a role in productivity. Statistically, you are telling that mean productivity of people with experience level A is different from the mean productivity of people with experience level B. Now you have to come up with a statistical solution also. And in order to arrive at this, we do hypothesis testing, which is used to either accept or reject your null hypothesis. If you remember from Greenbelt, we have null hypothesis. So there is an example given here also. Facts and data are used to either reject or approve or accept or reject. Prove, disapprove, accept, reject all mean the same. To either prove or disprove the hypothesis. Let's say the data shows experience level B is better for productivity. For example, based on this, there was some hypothesis testing done and experience level of B is better for productivity. That is what is the final solution. This statistical solution people will not understand. So you need to translate that into practical solution. What is a practical solution? Make changes in the process to incorporate the statistical solution. For example, we are only going to hire people with experience level B. That is the final solution that you're going to give to your HR department. To your management, you're going to go and say that. So you had a problem, you told me that experience level of employees is playing a key role in productivity. I've done statistical analysis using hypothesis testing. I proved it that people with experience level B have better productivity. Hence, I recommend to you that we have to hire only people with experience level B. That way our company productivity is going to increase. All right. Next thing is we need to understand more about hypothesis testing. It is used to prove which are the factors that are actually impacting the mean or standard deviation of the project Y? In Y is equal to f of x, what are those factors, inputs? Another name for x is inputs or factors. What are those factors in x1, x2, x3? What factor is impacting your Y? And since we are statistically describing, we are not directly telling what are the factors that are going to impact Y. We'll say what are the factors that are impacting the mean of Y. Mean is average of Y or standard deviation of Y. All right. Next thing is we want to see the impact of improvements after they are implemented. Right? After an improvement is implemented, we want to see what is the impact of that improvement. Third thing is we are looking into the p-value. P-value is critical in making any decisions. Yeah. So to determine if the statistical hypothesis is true or false, the entire population should be examined. And we know that it is going to become cumbersome, very difficult to examine each and every entry. Suppose I'm going to give you 1 million call records and I ask you on an average how many of these calls have exceeded 30 minutes. Then is it possible for you to go and look into each and every phone call and tell how many minutes each call has taken, then manually do it? It will be very difficult. Hence, what do? We do something called as sampling. We do random sampling or simple random sampling. SRS is what we call, is the best sampling technique. Right? There are multiple other sampling techniques, but SRS is considered to be the best, simple random sampling. So whenever we are working, even in real life, you will never get access to the entire population. If Apple iPhone comes to you and says that, boss, can you quickly check and tell me whether any of my mobiles have screen problems? Is it possible for you to manually go and check each and every screen of a million iPhones? It's not possible. So what do? Out of those million, you close your eyes, you'll blindly pick up probably some 10% of the entire 1 million, and then you'll check the screen of each and every iPhone. And based on that, you're going to make statements about what? About the entire population. Though you're working on this simple sample here, you're making statements about this entire population. And that is based on simple random sampling. The next thing is the conclusion. The conclusion for the population is based upon statistical significance, which is determined from sample data. So whenever you are making statements about the population, you always use a sample and then make the statements. From that sample, you are going to make statements about your population. That is what your entire hypothesis testing is all about. Yeah, we do all these things. So just give me 1 minute, a small correction here also, which I need to make. This is not in the content, but this is with respect to just small alignment. All right. Saving. All right. Okay. The next thing is, what is a hypothesis? Let me actually highlight. It is used to describe the assumption. Whenever you are using your sample and making statements about population, you are assuming. If I'm telling that all the iPhone users are happy, suppose there are a million iPhone users, I'm going to sample only probably some 1,000 or 10,000 people, and then I'm going to ask these people, or I'm going to quickly do some survey and check, do you like iPhone 6? Out of these 10,000 people, say 8,000 people say you that, yeah, I'm happy. So what statement are you going to make about the population? Yes, most of the people in the population are happy with the iPhone. But when you're making this statement, you're assuming that these 10,000 people are correct representation of this population. Let me tell you why you're assuming. What if by chance, there is very less chance, but what if by chance you have picked all the 10,000 people who actually like iPhone? Yeah, there might be many other people who might be dissatisfied with iPhone, but when you have simply picked up a sample, it so happened that everyone whomever you have picked are people who actually like iPhone. So the end result will be they like iPhone. So there are these kind of mistakes or errors that might happen. Hence you always say that I am assuming few things. Yeah. The next thing is hypothesis is based on the population parameters. Always we make statements about population using a sample. And whenever you're discussing about population, if it is mean or average, it is represented using Greek letter mu. If it is standard deviation, you use sigma square. Right? So that is the reason why in hypothesis testing you use only the Greek letters. Though you are working on sample, no doubt about that. Though we are working on samples, we are making statements about populations. That is the most important thing. Hypothesis must be clearly stated for correct decision making. And hypothesis is proved based on the evidence from statistical test. Some statistical tests we do, right? For instance, in our green belt we have done 2 sample t-test, we have done 2 proportion test, chi-square test, ANOVA, all these things. Right? In black belt we are going to look into many other hypothesis testing. All right, null hypothesis. Null hypothesis is a statement about population parameters. It is a one which is assumed to be true unless stated otherwise. Yeah, null hypothesis always assumes that everything is fine, no action required. Generally, it describes the present status. And alternative hypothesis is all about negating, contradicting, or it's a complement of the null hypothesis. Generally describes a difference. For example, if I say Anuj is better than Bharani, so do you know what null hypothesis will be? No, Anuj and Bharani both are same. Right? Both are same. But your alternative hypothesis is no, in fact Anuj is much more intelligent than Bharani. So that is your alternative hypothesis. So this is how you write your hypothesis. In null hypothesis you say everything is fine, I need not take any action. Here you are telling alternative hypothesis Anuj is more intelligent than Bharani. Right? So this is how you compose the statements. Alright. I think this example we have also discussed during a green belt. Let us illustrate the concept using a justice system. Null hypothesis says person is not guilty. No, he has not done any mistake. That is what the judge is going to fill his brain with even before he gets started. Alternative hypothesis says no, person is guilty. Now, strong evidence is required to prove a person guilty. That is, if you want to reject this, if you want to reject the null hypothesis, you need to have a strong evidence. Only if you have a strong evidence, you can reject this and you can accept alternate hypothesis. So in this graph, in this particular graph, look at this. HO, this is the region which says no, that person is innocent. And this small region says that No, that person is actually guilty. And when do you say that the person is guilty? Let us understand this. First, the judge is going to fill his brain with the thoughts that the person is innocent. Now there is an evidence. A person comes and says, so the murder happened in the 13th floor of the apartment, but I have seen this person walking across the apartment. Yeah, I've seen him come out of that apartment. Say, many people come out of the apartment, they get into the apartment. That is not sufficient. So till here, there was one evidence. There is another person who will come and say that, Judge, this person is actually guilty because I've seen him on the 13th floor at the time of murder. Then the judge will think, okay, evidence is a little strong, but it's not completely strong. 13th floor, there will be many flats on 13th floor. So how can I believe that he has actually committed that murder? Now, there is a third person who will come as evidence. He'll say that, Judge, this person was carrying a gun and he came out of the flat in which the murder has happened. Okay, now the evidence is very, very strong, right? So we have found evidence that this person has actually come out of flat in which murder has happened. That is the p-value. Okay, that is the probability that the person has actually committed a crime. And exactly this point, oh my bad, exactly this point, the moment you hit this point, you're going to say that yes, this person has committed a mistake, and that is when you're going to reject your null hypothesis. When do you reject your null hypothesis? P less than 0.05.
Bharani, can you give me just 1 minute?
Yeah, sure, Anuj.
Just give me 1 minute.
Yeah. All right. So when do you accept your null hypothesis? You accept your null hypothesis when p-value is greater than 0.05. So from here till here, you are continuously telling that p is greater than 0.05, p is greater than 0.05, p is greater than 0.05. As long as you say p is greater than 0.05, you are accepting the null hypothesis. All this while you have been telling that p is greater than 0.05. The moment you cross this point, you say that, oh my God, now p is less than 0.05. For me to accept null hypothesis, there is only a probability of less than 0.05%. That is when you accept or you reject null hypothesis and accept your null hypothesis, alternative hypothesis. All right, Anuj, is this clear?
Yeah. It's clear, yes.
Yeah, all right. Because this, yeah, I can hear you. I can hear you.
Yeah, it's clear so far, yeah.
All right. Now, let us go to the next thing, which is hypothesis testing and types of errors. Oh my God. I'm actually asked these things to be corrected, but all right. Whenever you're taking any decision, whether the decision might be you going to Australia, what is the chance that Anuj might go to Australia in Jan? You can do a hypothesis test on that also. What is the chance that Anuj might get a job as soon as he lands in Australia? Again, you can do a hypothesis testing. Any decision in your life. Today, will your wife be angry on you? You can do a hypothesis testing. Most often than not, she'll be angry. So you need not even do hypothesis in such cases. But in other cases, you can do hypothesis testing. All right. H naught is null hypothesis. Null hypothesis says set free the person because he's innocent. If a person is innocent and if you are leaving him, that is the correct decision. This is a correct decision which is described by 1 minus alpha. It is a probability of correctly accepting the null hypothesis, detecting no change when there is none. All right. In some scenarios, the person might be innocent, but you might make a mistake of sending him to jail. You might do such mistakes. So that mistake is type 1 error alpha. So normally you consider alpha to be 0.05. Right? In most cases, it is statistically proven that alpha value you can take as 0.05 or 5%. There's a 5% chance that you might go wrong. That's fine. 5% chance of I going wrong is absolutely okay for me. Right? So you cannot be 100% correct anytime. There's always a chance. There's always a probability that you might go wrong. All right. Next thing is a person is actually guilty and you have jailed him. So he has committed a murder and then you're sending him to jail. That's absolutely fine. Guilty is jailed. That's always represented by 1 minus beta. 1 minus beta is probability of correctly accepting your alternative hypothesis. You're detecting a change when there is one. This is fine. But in some other scenarios, a person might be guilty, but you might be setting him free. Wrong decision. If a person has made a mistake, if he has committed a murder, then send him to jail. If you're setting him free, then that means you're committing a beta error. That is called as type 2 error. Your A. Raja, the telecom minister, right? Though he is guilty, people have set him free. Lalu Prasad Yadav, though he is guilty, we have set him free. So in India, politicians...
India is hypothesis testing.
Yeah. For Indian politicians, we need not do any hypothesis testing. By default, it will be beta.
Yeah, Indian politician and Indian those religion people like the Sadhu Babas,
Yeah. Correct. So, Anuj, how is the development there in Gujarat? Is it actually the way? Okay, let me start recording.
Oh, good.
All right. Hypothesis testing errors. This is what we have to discuss. So we have already discussed in the previous slide that we have two errors. One is type 1 error. Type 1 error means a person has committed a mistake. Oh, sorry, a person is innocent, but you have put him in jail. That is type 1 error. You are accepting alternate hypothesis when null hypothesis was in fact true. It is also called as level of significance. Generally, it is a standard to limit the chance of making a type 1 error by setting alpha is equal to 0.05. That is, the confidence, 1 minus alpha is always called the confidence level of accepting HO when HO is true would be 95%. There is a 95% chance that you are going to release a person who is innocent. But there is always 5% chance that you might make mistake. That is type 1 error. Type 2 error. You accept null hypothesis when alternate hypothesis is in fact true. We typically set beta is equal to 0.1. That is, there is a 10% chance that you might make mistake. When a person has not made any crime, if a person has not committed any crime, still you're going to imprison him. That is type 2 error or beta error. Now this, the chance of making a type 2 error or beta depends on the alpha value also. What is the alpha value? And it is also going to depend on some sample properties. What is the sample size that you have selected? What is the centering? What is the standard deviation and all that? Centering is nothing but your mean or average, standard deviation. 1 minus beta is always called as power of test. Detecting the difference would be 90%. All right. We assume alpha is 0.05 and beta is 0.1. In most cases, we assume these values because based on many experiments, statisticians have come up with this number. Now, interpreting it for the legal system, we would tolerate a higher risk of setting free a guilty person. Type 2 error. Yeah, this is what happens, right? Setting free a guilty person is okay, but never an innocent person should be jailed. Hence, you're taking only 5% chance of type 1 error. That means you do not want to jail an innocent person. You're telling that only 5% of the times I can be wrong here. But setting free a guilty person, still that is a little okay. But jailing an innocent person is not at all okay. Hence, I'm giving only 5% chance of making mistake here. I'm giving a little leeway here and I'm telling 10% chance of making type 2 error is fine. That means you're setting free a guilty person. That's okay. But jailing an innocent person is absolutely unacceptable. That is given a 5% chance. Yeah. So with this, I'm going to stop here, Anuj. If possible, if you're going